Good morning. Next is mesomeric effect. Last class we have discussed inductive effect, and now the next is mesomeric effect, or another name is resonance effect. Mesomeric effect or resonance effect. What is mesomeric effect? The presence of certain groups adjacent to a multiple bond. What do you mean by multiple bond? Double bond or triple bond? The presence of certain groups adjacent to a double bond or a triple bond may create centers of low or high electron density in certain molecules by the delocalization of pi electrons or n electrons. So when certain groups are attached to adjacent to, not attached, when certain groups are adjacent to a double bond or a triple bond, will create centers of low or high electron density in certain molecules by the delocalization of pi electrons present in the multiple bonds, or what is that, n electrons, delocalization of lone pair electrons. This is called resonance effect, R effect, or mesomeric effect. Now, types of mesomeric effect. First one is minus R or minus M effect. Minus R or minus M effect. Now you can see that groups like CO group, NO2 group, CN, COOH, etc. when present in adjacent to a multiple bond may withdraw pi electrons of the multiple bond. So when groups like CO group, CN, COH, NO2, etc. are adjacent to the multiple bond, what will happen? These groups will withdraw the pi electrons of the multiple bond. That is electron displacement towards the attached groups. That means these groups will withdraw the electrons from the pi electrons from the double bond or triple bond. This is what is called minus R effect or minus M effect. Okay. So these groups will withdraw the electrons from the multiple bond. Let us take one example for minus R effect or minus M effect. Look at it here. Let us take an example for minus M effect or minus R effect. CH3, CH, double bond, CH, single bond. Suppose this group is coming CO group, or we can say, what do you mean by CO group? HO. The actual structure of this compound is CH3, CH, double bond, CH, single bond, CH, double bond O. Correct? This CO group is here. C double bond O group is here. Okay, now you can see that what is minus M effect or minus R effect. We can see that this bond will be moved towards, that means the bond means a pair of electron. Oxygen is more electronegative. This pair of electron will be shifted to oxygen. This is a pi bond. This pi electrons will be shifted to the oxygen. Then what will happen? This pi bond will come here. Okay, so what we get a structure like this. Look at it here. CH3, no change. Then CH. Okay, since this bond breaks from this carbon, and now the bond is between this carbon and this carbon. When the bond breaks from this carbon and it will come to here, this carbon is getting a positive charge, this carbon is getting a positive charge, and what will happen here? It will become then this single bond, and here this CH, and what will happen? Since this bond is shifted to here it will become a double bond, and here it is CH, and since this bond is shifting to oxygen is getting a negative charge. Once again, look at it here. CH3, CH double bond, CH single bond, CH double bond O. Oxygen is more electronegative. It will attract this pi electrons. This pi electrons will be shifted to oxygen. Then oxygen is getting a negative charge. Of course, you can show like this. Here a pair of electron and a negative charge, oxygen. And you can see that since this bond is breaking from this carbon, that time what will happen? This bond, this pi bond breaks from this carbon and it will be shifted to here. Then here it will become a double bond. Here it will become a double bond. Okay. Now, since the bond is breaking from this carbon is getting a positive charge. Okay, another example. Look at here. Another example. CH3, CH, double bond CH, single bond CN. Okay, CN means what is that? C triple bond N. In this case, what is happening in this? Look at here. Okay, this is first one, and in this case, you can see that again. This nitrogen is more electronegative. It will attract this pi electron towards it. Correct? This pair of electron, this pi electron will be shifted to nitrogen. That time what will happen? This bond breaks from this carbon atom, it will come here. Then what we get? We get a structure like this, CH3, then CH. Since the bond is breaking from this carbon is getting a positive charge. Then this single bond, then this CH. This bond breaks from this carbon and is shifting to here. Here it will become a double bond, and this C, then this bond is shifting to oxygen, remaining double bond En. It's a pair of electron and a negative charge. Clear? Here again we are coming back to our definition. What will happen? Due to the presence of certain groups, electron withdrawing groups, if electron withdrawing group is present, we can see that certain groups will create centers of high or low electron density. What do you mean by that? Here you can see that since the electron is shifting from here it is low electron density, and here is a positive charge is created. Since this pair of electron is shifting to oxygen is getting a negative charge, high electron density. So molecules, in certain molecules will create centers of low electron density and high electron density. Here it is low electron density and here it is a high electron density. Okay, this type of effect is known as mesomeric effect. Here, if electron withdrawing group is present, then this particular effect is known as minus M effect or minus R effect. Now here you can see that the pi electrons are moving towards the attached group. This is our pi electrons. Pi electrons are moving towards the attached groups. Here also you can see that the pi electron is moving towards the attached group. Okay, this type of effect is known as a minus M effect or minus R effect. Here you must see that the double bond and the double bond present in the attached group and the double bond present in the carbon chain, they are adjacent, they are in conjugation. What do you mean by in conjugation? Here is double bond, here is single bond, here is a double bond. That means these double bonds are in conjugation. This type of effect is known as minus R effect or minus M effect. Is plus R effect or plus M effect. Plus R effect or plus M effect. Groups like OH, OR, NH2, Cl, etc. having lone pair of electrons. So here you can see that oxygen is having lone pair electron. Here also oxygen is, here nitrogen is having lone pair electron. Cl is having this type of groups having lone pair of electrons when attached in adjacent to a multiple bond. Will donate electron pairs in the direction of the multiple bond. Will donate electron in the direction of the multiple bond. In the previous case, minus R effect or minus M effect, the group will withdraw the pi electrons of the multiple bond towards the group. But here it is not like that. The electron pair in the will be shifted in the direction of the multiple bond. So example CH3 CH double bond CH single bond OH single bond OH. See here OH is attached. Now in this case you can see that here oxygen is having a pair of lone pair electron. Look at it here. When this, what will happen to this lone pair? This lone pair electron will be shifted to here, correct? Then what will happen? This bond, this pi electron will be shifted to this carbon. Okay, so what we get? We get a structure like this: CH3 CH. Since this pi electron is shifting to this carbon, the carbon is getting a pair of electron and a negative charge, and here it will become a single bond CH double bond OH. Since this pair of electron is moving from oxygen, oxygen is getting a positive charge. Okay, so this effect is called plus R effect or plus M effect. The second, another example we can say CH3 CH double bond CH single bond Cl. Suppose this is the condition. Now what is that? You can see that a atom or a group of atom having lone pair electron is adjacent to a multiple bond. Adjacent to a multiple bond. This effect is happening when electron withdrawing or electron donating group is adjacent to a multiple bond. Here electron donating group. So what will happen? This pair of electron will be, lone pair electron will be shifted to here. So here it will become a double bond. That time this pi electron will be shifted to this carbon. So what we get? We get a structure like CH3 CH. Since the bond is shifting to carbon, carbon is getting a pair of electron and a negative charge. And here it is single bond. Here it is CH. And here it will become double bond. Since the electron is moving from chlorine is getting a positive charge. Here also you can see that centers of low electron density and high electron density are created. Okay, this type of effect here, electron donating effect in the direction of the electron. Electrons or lone pair electron is donating in the direction of the multiple bond. It is coming this way. Okay, in the previous case this pi electron was shifting the opposite direction. That means in the direction of the, towards the direction of the attaching group, towards the direction of the attached group. Here you can see that the electrons are moving towards the direction of the double bond, towards the direction of the double bond. This is what is called the plus R effect or a plus M effect. Okay, thank you. We continue in the next class.